These are examples from Lesson 3A, Equations of Parallel and Perpendicular Lines. In this video, you will learn what the standard form for the equation of a line is, how to use it to graph lines, and how to write a given equation into that form. You will also learn how to determine whether two lines on the coordinate plane are parallel, perpendicular, or neither. Example 1. In this example, you will write a given equation in standard form. Write the equation in standard form, then identify the coefficients A, B, and C. Remember that in standard form, A cannot be negative. It has to be a whole number. And then all three, A, B, and C, must be whole numbers. B and C have to be integers. There shouldn't be any fractions or decimals. So standard form is written AX plus BY equals C. Notice that X and Y terms are together on one side and the constant is on the other side. Starting with part A. In part A, we have what looks like it's in slope-intercept form, y equal mx plus b, but they want us to write it in standard form. Anytime you have a fraction in an equation, you can get rid of it by multiplying both sides of the equation by that denominator, or the denominator of the fraction, or by the least common denominator of all fractions in the equation. So if we multiply both sides by 4 here, we can get rid of this 4 and we won't have to deal with fractions anymore. When you multiply both sides of an equation by any number, it means you're multiplying every single term in both sides by that number. So I'm going to go ahead and show that. We're going to multiply both sides by 4 like this. So that means that's 4 times y equal 4 times 1/4 x minus 4 times 2. So that gives us 4y equals, and the 4's divide out. That we did that by design. We get 1x or x minus 4 times 2 is 8. Now we got rid of our fraction. We need to put it in standard form. The x needs to be where the y, over where the y is, so we subtract x from both sides. We get negative x plus 4y equals negative 8. Now, a lot of students might leave this. Be very careful, because this is not supposed to be negative. As I mentioned before, this has got to be a whole number. It can't be negative. So how do we change it? How do we get rid of that negative? You can either divide every term or both sides by -1, or you can multiply both sides by -1. Either way will give you the same result. I'm going to divide all terms by -1, or both sides, every term. Negative 1x divided by -1 is positive x. Negative 4y divided by -1 is minus 4y. In other words, all the signs change to their opposite. And there we have standard form of the equation of this line, where A is the coefficient of x, which is 1, B is the coefficient of y, which is -4, and C is the constant, which is 8. Part B, y plus 3 equals -5 times x minus 11. This happens to be, if you'll notice, in point slope form. Nevertheless, we need to put it in standard form. First thing we want to do is get rid of the parentheses, so we use the distributive property. We have y plus 3 equals -5x plus 55. And then we don't have any fractions to have to deal with, so the next thing we do is we want to get our x and y together, so I'm going to add 5x to both sides, eliminating it over here. We have 5x plus y plus 3 equals positive 55. Now we need to get this 3 and 55 to combine, so I'm going to subtract 3 from both sides, and that gives us 5x plus y equals 52. This is in standard form. This is positive, it's a whole number, and the coefficient and constant here are integers. So there it is, where A is the coefficient of x, which is 5, B is the coefficient of y, which is 1, and C is the constant, 52. Example 2. In this example, you'll learn to graph a line without using slope. The slope. Use intercepts to graph the line represented by the equation 2x minus 5y equal negative 10. Now, one of the reasons why we learn this method is because many times when you get up to pre-calculus and AP calculus, you'll find yourself using this method and it becoming pretty convenient many times in those two courses. So I'm going to show you how to do this. Well, to use intercepts of course are where the graph crosses either the x-axis or y-axis, and of course the x-intercepts where it crosses the x-axis, and the y-intercepts where it crosses the y-axis. A and B we call them. And so if we're going to do that, we have 2x minus 5y. We don't have to manipulate the equation, we just leave it the way it is. Let's start with the x-intercept. To find the x-intercept, notice that wherever a graph goes through the x-axis, the ordered pair for the point anywhere on there, the y-coordinate is going to have to be 0. For instance, this point right here, the point there, the ordered pair for it is 3, 0. The point here is negative 1, 0. The y-coordinate has to be 0. So we let y equal 0. So when you're looking for the x-intercept, you let y equal 0, the other variable. So doing that, we just plug the 0 in and solve. 2x minus 5 times 0 equals negative 10. This gives us 2x minus 0 equal negative 10. This gives us 2x equal negative 10. Divide both sides by 2, and x is negative 5. So in other words, when y is 0, x is negative 5. Therefore, A, the x-intercept, is negative 5. Therefore, we have the point negative 5, 0 to graph. So let's graph that. Start at the origin, go to the left 5. Don't go up or down any. There's our... Okay, now once we get the other point, we'll have 2 points and we can graph our line. Of course, it'll be crossing somewhere on the y-axis. The y-intercept, you pretty much do just the opposite. If you want to find the y-intercept, the x-coordinate for that whatever point is on there has to be 0. So we let x equal 0. Go back to our equation and start over, substituting in x for 0 for x. So x 2 times 0 minus 5y equals negative 10. This gives us 0 minus 5y equal negative 10. Negative 5y equals negative 10. Divide both sides by negative 5, get y equal positive 2. So therefore B is our y-intercept is 2. Therefore we have a point at 0, 2, where x is 0. So we graph that point, 0 to the right or left, and then up 2, 1, 2. So here's our other point. Take a straight edge, practice best practices for graphing. Make sure you clear the graph on either side, and be very careful since you're only plotting 2 points to make sure that it's correct in the correct location. Clear across to the line, and 2x minus 5y equals negative 10 is the equation of our line. Example 3. In example 3, you'll use what you know about slope and parallel lines to determine how two lines relate to each other. Are lines L1 and L2 parallel? Explain. Now we don't actually need the equations of the lines to compare them here, just their slopes. So we wouldn't actually have to write the equations of these two lines unless you just wanted to, or if they asked you to. But so we just need the slopes. So what do we know about parallel lines? We know that their slopes have to be equal if they're parallel, or by the biconditional we went over in the notes. Line 1 is parallel to line 2 if and only if the slope of line 1 is equal to the slope of line 2. So if we can find the slopes of both these two lines, line 1 and line 2, if they're equal to each other, then we know we have parallel lines. If they're not equal to each other, then no parallel lines. So the slope formula, M stands for slope. I'm going to substitute in the slope for line 1. Line 1 over here, if you'll notice, has 2 points given to us, written on the line. I'm going to let this be my first point, this be my second point. So this would be x1, this would be y1. Down here we have x2 and y2. So starting with our y coordinates, y2 minus y1, we have negative 4 minus 5 over the difference between the x coordinates, x2 minus x1, or 2 minus negative 1, equals, we're going to check to see if it is equal to, the slope of line 2. Here's line 2. I'm going to let this be my first point, this be my second one. So this would be x1 and y1. Down here, this would be x2 and y2. So finding the slope using the formula, y2 minus y1, we have negative 4 minus 3 over, back over to the x coordinates, starting with x2. x2 minus x1 would be negative 1 minus negative 3. Be careful with those double negatives. Make sure you account for them. Okay, so then from this point on, we just work the left side of the equation, the right side of the equation to see if they're equal. Continue all the way through. Negative 4 minus 5 is negative 9. 2 minus negative 1 is 2 plus 1. And then over here, negative 3 minus 3 is negative 7. And negative 1 minus negative 3 is negative 1 plus 3. Then we have on the left side negative 9 over 3. On the right side we have negative 7 over 2. Negative 3 over 3 reduces by 3, or simplifies by 3, and we get negative 3. And we still have negative 7 halves. Well, obviously 3 and negative 7 halves do not equal each other. Therefore, line 1 is not parallel to line 2, because the slopes were not equal. Example 4. In example 4, you learn to write the equation of a line that is parallel to another line. What is the equation in slope-intercept form of the line parallel to line 1? And they give us line 1 here. That contains the point 3, negative 5. Okay, so what they're saying is they give us a line, line 1, and they want us to find a line that's parallel to this one that goes through this point. Okay? What do we know about parallel lines? Their slopes are equal. So again, we use that same property. So what do we need to do ultimately? We need to look for line 2. That's what they're asking for. So line or line 2. Find it. The equation for it. Okay, so using what we know, we've got L1 has to be parallel to L2 if and only if the slope of line 1 is equal to the slope of line 2. Well, do we know the slope of line 1? Yes, we do. This is in slope-intercept form, so this has to be the slope of line 1. So substituting in the slope of line 1, right here, we have negative 3 equals the slope of line 2. In other words, the slope of line 2 has to also be negative 3. And then it has to go through this point. So this is our one point on our new line. So this would be x1 and this would be y1. Since we have a point on our new line, and since we have the slope of our new line, point, slope, we use point, slope form. So by the slope, or excuse me, point, slope form, which is y minus y1 equals m times x minus x1, we can substitute in these values, which is something you've done before. So here we go. Y minus y1, which is negative 5, equals m, which is the slope, negative 3, has to be the same as the slope, times x minus x1, which is 3. Now, simplifying, we want to put it in slope-intercept form, so this would be y plus 5 equals, using the distributive property, negative 3x plus 9. Then we need to get y by itself, so we subtract 5 from both sides, and we get y equals negative 3x plus 4. This is our new line, line 2, and it's parallel to this line. See how the slopes are the same? but goes through a different point. That's why these numbers are different. Here is a graph of this situation. This was line 1. If you were to graph it, it would be there and located there. And then the point that we were given is way over here. And we just found the line that's parallel to this one, line 2. Example 5. Here in example 5, kind of like example 3, you use what you know about slope and perpendicular lines to determine how two lines relate to each other. Are lines 1 and 2 perpendicular? Explain. Here we've got two lines again. We're trying to see if they're perpendicular, so all we need to do is look at their slopes. We don't really need to actually come up with the equations of their lines. Here we have line 1 and line 2. So again, if line 1 is to be perpendicular to line 2, then it's going to be true that the slope of line 1 times the slope of line 2 has to have the product of -1. This is something we went over in the notes. So we're going to use this, and if this is true, then we can say that the two lines are perpendicular. So let's start off with the slope of line 1. Here's line 1. Line 1 has 2 points given to us on it. So let's let this be our first one, this be our second one. So this would be x1, this would be y1, this would be x2, and y2. Alright, taking the difference of the y, or change in y's, it's y2 minus y1. We have -4 minus 2 over the difference in the x's, or the change in x, x2 minus x1, 0 minus -4, times, now for the slope of line 2. Here's line 2. Here's 2 points given to us on it, one here and one here. I'm going to let this be my first one. This would be x1, this would be y1, this would be x2, and this would be y2. Okay, starting with y2 minus y1, we have -3 minus 3. And then going back over to x2 minus x1 would be -5 minus 4. Equals, we want to see if it's equal to -1, the product of -1. So here we go. Let's take care of this. -4 minus 2 is -6 over 0 minus -4 is 0 plus 4 times -3 minus 3 is -6 over -5 minus 4 is -9. And we're going to see if that eventually equals -1, the product. This gives us -6 over 4 times, negative divided by negative is positive, and then we have 6/9 reduces by 3. 3 goes into 6 twice, 3 goes into 9 3 times, so we have 2/3 positive. And -6/4 does reduce, but it remains negative. 6/4 reduces by 2, 2 goes into 4 twice, 2 goes into 6 3 times, and we get -3/2 times 2/3 equals -1. Okay, multiplying these two together, notice the 2's will divide out, and the 3's divide out. We get -1 over 1, or -1 times 1 over 1, which is 1. And what's -1 times 1? -1. Therefore, line 1 is perpendicular to line 2 because the slope's product was -1. Example 6. In this example, you learn to write the equation of a line that's perpendicular to another line. What is the equation in slope-intercept form of the line parallel to line 1, and they give that to us, that contains the point 7, -4? This is similar to example 4 that we did, except this time we're looking for a perpendicular. So, what do we know about perpendicular lines? Once again, we know that if two lines are going to be perpendicular to each other, or they are perpendicular if and only if the slope of one of them times the slope of the other one equals -1, and the product is -1. So we're going to use that fact again. Well, this time we have the slope of one of the lines. This is in slope-intercept form. This is our first line. This one right here. The slope would be -3, so we substitute that in. Times, we need the slope of our second line because they asked us to write an equation for it. So this is our variable, m sub l sub 2. This whole thing is a variable, equals -1. Now we solve for the slope of line 2. Well, since -3 is being multiplied with it, divide both sides by -3. Those divide out, and the slope of line 2 is equal to +1/3. So now we have the slope of our new line, and it's got to go, our new line has to go through this point. So this is the point we're going to use. This is our x1 and our y1. So since we have a point on our new line, and we've got the slope of our new line, we can use point slope. The point slope form, which once again is y minus y1 equals m times x minus x1. Substituting in these values, we get y minus -4 equal the slope 1/3 times x minus x1, which is 7. Then they want it in slope-intercept form, so we're going to solve for y eventually here. So we have y plus 4. Using the distributive property, we have 1/3 x minus 1/3 times 7. This gives us y plus 4 equals 1/3 x minus, and then 1/3 times 7, there's nothing that will divide out, so we get 7/3. Then we've got to get rid of the 4, so we subtract 4 from both sides. When you're finding slope-intercept form, many times you get stuck with this fractional situation because y has to be by itself. When you're finding standard form, usually that seems to be a little easier with fractions because you can always get rid of them. But anyway, so this gives us y equal 1/3 x minus, actually this is negative times negative minus negative, excuse me, negative times negative, negative plus negative, I'm sorry. So it's going to be more negative. This would be 7/3 plus something in thirds. Well, it's 4/1. 1 times 3 is 3, so 4 times 3 is 12. And actually this is supposed to be minus. So we have y equal 1/3 x minus 7/3 minus 12/3 means that we have to take -7 plus -12, and that would be plus -19 or minus 19/3. Okay, so here you have the equation that's perpendicular, the line that's perpendicular to this one that goes to this point. And here is a visual of it on a graph. Here was our original equation, the original line, line 1, and our point was 7, -4, and the line that we just came up with is this one right here. It happens to go through, by the way, the y-intercept is at -19/3 right there. So it's perpendicular. Example 7. In example 7, you practice writing an equation that's already in slope-intercept form into standard form. Write the equation you found from example 6 in standard form, and I've written it down already. So we're going to take this and find standard form from it. Remember, standard form, ax plus by equals c. A, b, and c cannot be fractions or decimals, and a has to be positive. So first thing we can do is get rid of the two fractions. Since both of them have a denominator of 3, we multiply both sides by 3, which means we have to multiply each term by 3. So this is 3 times y, or 3y, 3 times 1/3 x, minus 3 times 19/3. Well, this gives us 3y equals, the 3's divide out, and we get 1x or x. The 3's divide out, we get 19/1 or 19. Now we need to get the x term over here with the y, so we subtract x from both sides. We get -x plus 3y equals -19. Again, this leading term, the A cannot be negative, so we want to get rid of that. So I'm going to divide each and every term, or both sides, by -1. And we get positive 1x minus 3y equals positive 19. And there is the equation of this line in standard form. Example 8. In example 8, you apply what you learned about relationships between two lines that are either parallel or perpendicular. The baseball field below is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line that's shown. So the batter's here, hits the ball, it's a ground ball, it keeps going this way. So it continues on that way. Then the player, which happens to be located at the ordered pair, 110-70, 110 to the right, up 70, that's this player right here. He starts running along a path that's perpendicular to the path of the baseball. What is the equation in standard form of the line on which the player runs? So he's going to start running toward the path of the ball, perpendicular to it. And they want to know what's the equation of this line right here. Okay, so several things we need to do. And the first thing we need to do is we need to find the slope of this line right here, because if we can find the slope of this one, then we can find the slope of this one, because we know how slopes of perpendicular lines relate. Then once we find the slope of this one, we've already got a point. This player's was at 110-70. This will be our one point on our line that we know. And we can find the line that's perpendicular. So find slope of this pathway. So baseball path line. Okay, so the first thing we can do is we can say the slope of this line is going to be, we need 2 points on this line. So you can choose any two that you have. I would stay within the ones they drew here. There's one here, there's one here, there's one here. I'm going to just choose, I guess, 0, 0. And I think I'll skip that one and use, how about this one? This would be 60, 20. You could have used this one, it doesn't matter. Any two of those. Okay, to find the slope, this would be x1, y1. This would be x2, y2. So this would be y2, which is 20, minus y1, which is 0, over, back over here, 60 minus 0, which gives us 20 to 60. Reduced by 10, that gives us 2, 6. Reduced by 2, that gives us 1/3. So our slope of our original ground ball line path there is 1/3. So 1/3 is the slope of the baseball path. I'll just write baseball. Now, we need the slope of our new line. It's perpendicular to it. So we have to use what we know about slopes of perpendicular lines. The slope of the baseball path times the slope. I'm going to call this the player line. Has to equal -1. Well, we know the slope of the baseball is 1/3, so we substitute that one in, times the slope of the player equals -1. So I have an equation, 1/3 x equal -1. To get rid of the 1/3, we can multiply both sides by the reciprocal, 3 over 1, or 3. The 3's divide out, we get just the slope of the player left as our variable. -1 times 3 over 1 is just -3. So now we know the slope of the line of the path of the player who's running toward the ball. And we also know at least one point on that path, which is the player where he started, where he was stationed at. So this would be x1 and this would be y1. So using this point and this slope, we can use point slope form. y minus y1 equal m times x minus x1. So substituting in with this point and this slope, we have 70. Excuse me, y minus 70 equals the slope, -3, times x minus x1, which is 110. Now, getting rid of the parentheses, we have y minus 70 equal, using the distributive property, -3x. -3 times -110 is plus, 330. And then adding 70 to both sides, we get y equal -3x plus 400. Now, they asked us to write it in standard form. This won't take us too long. Let me rewrite it here. The only thing we need to do is get rid of the -3x, bring it over here, which means we add 3x to both sides. And we get 3x plus y equals 400. This is the equation of the player pathway toward that ball.